Good morning, everyone, and welcome to this webinar dedicated to AI agents and their role in the digital advertising market. Today, we will discuss how these technologies are transforming the management of online advertising campaigns, improving efficiency and results. To guide us in this conversation, we have with us two experts from Mint who will help us better understand the potential of this new trend for our industry. First of all, good morning to the Business and Integrations Advisor Domenico Fumagalli.
Good morning, everyone. It's a pleasure to be here.
Good morning, Domenico. So to put your job title in more intuitive terms, you design AI agents and help companies adopt them, right?
Exactly. I have this wonderful dual perspective on AI agents in my daily activities.
So in a moment, you'll help us learn more. But in the meantime, good morning also to the Senior Sales Account Specialist, Christine Appelhoff.
Good morning. Thank you so much for the invitation, Simone.
Thank you, Christine. So, you have extensive experience in marketing and technology, and at Mint, you help companies make the most of this new trend, correct?
Correct. You perfectly summarized it.
Great. So, before we dive in, I'd like to remind everyone that the webinar is being recorded and you will soon receive the full recording to watch later. This is for those who can't be with us now or won't be able to stay until the end. I also encourage everyone following along to ask their questions using the chat, which should be visible on the right side of the screen, Domenico. We will try to answer you during the session. At this point, I'd say we can move on to the first part of the presentation, which will be given by Domenico. He will help us better understand what AI agents are and how they work.
Thank you. Thank you very much, Simone. As we were saying earlier, I have this great perspective from two different viewpoints, great for me at least. Nowadays, we hear a lot about transitions, economic, energy, democratic transitions, and so on. We also have one in artificial intelligence. Certainly an absolutely fascinating, impactful, and transformative transition that began in the 1950s. Unfortunately, I don't have the time to go through all its nuances, but we need to focus on what truly matters in this transition for business. In particular, we started from an era that we call predictive AI, in which the applicability, the practical scope of the models being created was quite limited. Typically, companies would develop one model for a specific task, and in practice, the application of that model was quite restricted. The model was good at performing that specific task. Subsequently, the second era was that of generative AI, dominated by GPTs, generative pre-trained transformers, which is characterized primarily by an expansion of the practical scope for a very specific reason. And transformers, the beating heart of this second phase, are a type of model that is extremely proficient at understanding and generating language, predicting the well-known next word based on a sequence of preceding words. Fantastic. So in this second era, what do we find ourselves holding in our hands? We find ourselves with models that are extremely good at understanding and generating text, essentially at speaking. However, we are still in a world where we start with text and in turn generate more text. Essentially, at this stage, this artificial intelligence only speaks and listens. It doesn't do anything yet. To perform actions, a series of structures need to be put in place around these models to enable them to interact with their surrounding environment, thus transforming them from merely highly intelligent and incredibly smart parrots into actual agents. Intelligent structures that can decide what to do and seamlessly and effectively execute tasks. The widespread and increasingly inevitable use of these AI agents should lead us to the much discussed and widely anticipated phase of artificial general intelligence. A phase for which, Simone, I fear we would need an entire webinar. Today we are laser focused, as the Americans say, on AI agents. But what are these AI agents? This question certainly needs an answer. Indeed, we will provide a working definition, but we shouldn't dwell on it too much, because it is an evolving topic. There are no universally agreed upon definitions of AI agents. There are many, and depending on the application domain, they tend to change a bit. In my opinion, rather than focusing on the different definitions of an agent, I personally find it much more interesting to look at what agents actually exist and what types of agents are currently out there. They are already actively taking the stage and beginning to interact with us. Specifically, in particular, I would like to show you 4 types of agents. Once again, in essence, these are systems in which a large language model essentially makes the very careful and thoughtful decision on what the next step should be, with precision and accuracy. This is the only definition that, in my opinion, gives us the necessary tools to approach the world of agents. Let's start with our first case. First of all, I want to apologize right away because I will be making heavy use of diagrams. I'm hated in the office for this. There isn't a meeting where I don't have a diagram, but I believe that, given the nature of the subject, it's much easier to draw a process and break it down into small components rather than just explaining it to you. Let's start with our Reason and Act agent, abbreviated as REACT. It is the original type of agent, so essentially the first type of agent to be implemented in real-world applications at scale and so on, and is also probably the most widely used agent today. How does it work? It works like this. In yellow, also for the next slides, you can see the points where a human usually interacts, whether it's an input or an output. In light blue, you can see all the processes that are effectively managed by artificial intelligence, while in white, where it's blank, you will find processes that are purely traditional programs, meaning there is no artificial intelligence involved in those parts, those white dots that you will see in this diagram. Fantastic. Let's start with a case related to our world of advertising. Let's say that my task is to perform analysis. I say, okay, I interact with an agent and say, look, I need to conduct an analysis on some campaign data. Fantastic. I pass this request to an agent. What does the agent have? It has access to certain tools, or at least a list of tools with descriptions of what each tool does. In this case, for our example, we can say, look, you have functions available for analysis, and you also have an API from which to retrieve the data. The agent, given the user's input and the list of tools at its disposal, asks itself a question. Do I need to call a tool to answer the user's question? If the answer is yes, it selects a tool and executes it. The agent sends the execution message to the program, and the program, in this case, hopefully starts by retrieving the data from the API. The tool also sends a response to the agent, which reads it, and the agent processes the output. It says, okay, fantastic, I have extracted the data, and I have a message confirming that I have the data. Great. Now to respond and fulfill the task I was given, I also need to perform an analysis. So I call another tool to answer this question from our user. So I call another tool, in this case, the analysis tool. The tool is executed and I get the analysis result, which could be, I don't know, a correlation analysis. Great, let's move on. This function gives me an answer. It provides the correlation, an analysis of our campaign data. The agent thinks, oh, this happened, that happened, and something else happened. I have all the elements to respond to my user. The answer in this case, hopefully, is yes. So I actually provide the answer to the user, and the user says, fantastic, thank you so much, agent. Or, no, I don't like what you said, I'm leaving, goodbye. Whether the feedback is positive or negative, this feedback is recorded and stored within the agent's memory. And what is that memory used for? To enhance and optimize the instructions for that agent carefully, so that if something happens, this system can react appropriately. In fact, it is a system that operates in a loop, meaning it keeps calling tools until it believes it has completed a task. Great, and this is excellent for more creative tasks or for assistant systems where there is constant interaction with a human. Moving on. On the downside, we can't give it more than 5 tools without experiencing a drop in performance on one hand, and on the other, the sequence of tools to call is entirely based on the reasoning of this agent, so we have no control over it. So, let's say that this is perhaps the main issue with this type of agent, and it's also what leads us to a second modified version. Let's call it a cousin, maybe a bit more in quotes, boring compared to our React agent, which is extremely good at creative tasks. The boring cousin is called router. The router simply directs the request based on a given input. The prime example to illustrate this, I believe, is customer service. Let's say I call a TV service because my decoder is no longer working. I have a router agent that, depending on my request, might send me to technical support, or maybe to someone who shows me new offers. Or, if I didn't understand the response, it sends me back to ask for more information from that user. Do you see what changes compared to before? The difference is that the router does not execute the command, but simply directs it. It no longer holds information about the tools, but rather about the process. A router agent is in fact the backbone of many multi-agent systems. It is widely used precisely because it is very lightweight, and most importantly, it is separate from the execution of the tool. So it can focus solely on the task of routing, essentially, and directing the user's input. The downside is that it operates on predefined tasks. These predefined tasks must be pre-programmed by an engineer, meaning it follows predetermined paths. Therefore, it is not as flexible as the React agent. Then we have another type of agent, which is the agent specialized in reflection. What does it do, essentially? Let's say that in this case, we need to generate a media plan. Or a media plan and a generator creates the media plan for us. Our reflection agent, which you see in red, takes that input, checks it against certain criteria, and essentially determines whether it is acceptable or not. If it is acceptable, I proceed with the request. If it is not, I send back feedback and have the media plan redone. In this case, the generator redos the media plan. We check it once again and provide feedback to the user if it is acceptable. On the positive side, it is used to eliminate or at least manage the so-called snowball effects in agent systems. What is the snowball effect? The snowball effect occurs when a small error in an agent is not detected by the system and is effectively passed on to subsequent workers. And the problem keeps growing bigger, which is why it is called the snowball effect. On the downside, it adds costs and latency to a system. Clearly, I need to think it through, so I take an extra step, meaning my final response to the user will obviously be slower. There is another reason why it might be slower, and that is the type of models generally used, which are more effective in this role. Each agent can have an underlying model and a specific type of model. The models used in this case are the well-known reasoning models, such as OpenAI's latest, the brand new Claude 3.7 Sonnet, or even the famous, the highly renowned R1 from DeepSeek. These are all models that are good at reasoning. However, being good at reasoning comes with its own considerations, so this is definitely something to keep in mind. Very interesting. The last type of agent we'll look at is the orchestrator. The orchestrator does something quite fascinating. It takes an input, breaks it down into subcomponents, assigns a series of other agents, and essentially makes them work in parallel on each of these inputs. Let's say, in the case of a media plan, okay, I need to create a media plan. The planner breaks it down and creates a specific plan for each channel, dividing it by segmentation, geography, and so on. That planner will then essentially launch a series of worker agent planners that will work on each individual part of the plan. In the end, usually in this system, there is an information collector that gathers everything together and passes it to the user. Pros, suitable for very sophisticated tasks, ideal for initiating the agentic flow. Cons, requires parallel execution and comes with a whole set of challenges. On the deployment side, this includes the use of the well-known rate limits, meaning the number of requests I can make per minute to the proprietary language model API if they are being used. Great, moving on. The level of delegation of these agents clearly changes depending on the task. If I need to work in an information gathering perspective, retrieving information with an agent, I can essentially request this directly from a language model. I have no actions to take. Fantastic. Now, in the case of a single agent, beyond just requesting information, I actually have tools to call, tasks to perform, right? If I am within the scope, within the scale of about 5 tasks to complete, I can use a React agent, as we saw earlier, and effectively manage a task. A multi-agent system, on the other hand, allows us to handle very complex tasks, such as managing cases where, for example, I give you documentation and you need to resolve an issue that requires analyzing GDPR compliance, how the Italian law applies, and its tax implications. Once you have a solution to this problem, send me a report. This is an entire business process, right? It may also require multiple business functions, as in this case, and in such a scenario, I need to turn to a multi-agent system. A single React agent, for example, would literally break down in this case. Just a quick aside regarding data, not important in itself, but it helps us understand something. In my opinion, it makes us understand one thing. An important point. This is research conducted on a sample of American companies that revolve around technology and services, so they are generally the companies that have implemented agents the most. We see that half of them say they already have agents, and 3/4 say they want to implement them and will have them in the future. However, the most interesting thing, in my opinion, is to see where greater effectiveness is perceived. The general cases. It is said that general cases are easier to manage than specific ones. Look at the gap in perceived effectiveness between research and summarization on one side and data transformation and enrichment on the other. In advertising, we know perfectly well how particular and rich in nuances the data transformation process can be. What does this lead us to conclude? It leads us to conclude that we need an architecture, an agent architecture that is generally specialized to handle certain types of cases. So determining experimentally which architecture is the right one is essentially the job of those who create these agent systems. There are 2 architectural principles, or rather 2 architectural styles, that can be used to create these systems in which the agents we discussed earlier interact with each other. Then, an architecture could be flat or an all-purpose architecture, which is excellent for open-ended tasks. Or on the other hand, it could be a task. There are other types of architectures known as sequentialist, which are more suited to handling problems, tasks that can be solved by a process that can, let's say, be predetermined or pre-configured. But even here, rather than talking about it, I think examples speak for themselves. This is a famous architecture called Swarm. You've probably seen it on LinkedIn. Swarm, what is that? It's a type of all-purpose architecture that connects each agent with the user and with all the other agents. This means that, in this case, the analyst can talk to the reviewer, who can talk to the researcher, who can talk to the user. What is its strength? It's very flexible and particularly suited for creative workflows. What about the cons? That I have no control over the trajectory. Very well. Now, the sequentialist alternative. You can see that these are generally more complex architectures, more explicitly defined. And in this case, we see all the agents we mentioned earlier in motion interlocked with one another. We start with a router that rotates among 3 options. We have a pattern orchestrator that launches React agents, which in turn work on a specific part of a plan in parallel. This process is then automatically collected, and in the end, we reflect on whether to redo this entire flow or not. This is an example of a sequentialist architecture. But more than the content itself, what I would like you to appreciate is the architectural difference between these 2 models.